On the axis, you have to find out the magnetic field, sorry, gravitational field strength. Let R be the radius. At a distance x, at point P, you have to find out the field strength. It's a thin circular disk. Later on, I'll color it. Okay, now we'll save some time. What is the mass of circular disk? Let it be m. So we'll define the sigma. What is sigma? Mass by, can you remember, area density? So on the axis, what is the gravitational field strength? Okay, slowly we'll take some different shaped objects here. This is again, ring is a fundamental. The ring is going to help us a lot. I'm telling this one. If you know the expression for gravitational field strength due to ring, no, all are interrelated. What is a disk? So shall we assume it made up of the elemental rings? So we'll assume that to be a ring. The disk is made up of elemental structures ring. Then due to elemental ring, first we'll find out the field strength and on the axis at point P. Then we'll integrate, we'll get the due to total disk here. So I'll begin with the okay, let this be the elemental ring. Thickness of this, let it be dr. No, this is what is that blue color one? That blue color is elemental ring, and what this is a disk. Huh? First, we'll calculate what is the mass of the disk. What is the mass of the disk? dm sigma into 2 pi r dr. I think all of you know all this. What is dr? Dr is the width of that one. No, where is this? So shall I say this line? This line is axis on the ring, and O is the center of the ring. So what is the field strength? First, due to that elemental ring here, let that be dE. So what should be dE is equal to? Again, we do all these assumptions, no? Let this be theta. Now, directly, I think if you can write formula, you'll be on safer side. Again, don't derive for sir elemental ring how much. Directly you go for that one. What is the formula? For elemental ring, what is the formula? Just now we have derived the conclusion. I'll take you back to the gmx by r square plus x square to the power of r by 2. So in place of m, what you should write? Look at this equation, corner. In place of m, dm. In place of capital R, small r, and everything is same. Okay, I get this. So directly I'm taking, again, don't do, on elemental ring, again, don't assume thing. Already you did. So you should take help of this particular formula. Fine. Okay, now let's get into the derivation part. It's a very good topic for students to test their mathematical ability, geometrical ability better. Let's not say mathematical, geometry, that one. How good you are in making imagination of the structures, different physical shaped structures. That's what like we are trying to build your imagination power, nothing big. So this should be G dm x by r square x square to the power of 3 by 2. Small r is this one. So what to do? What is dm? Substitute this. Sigma 2 pi r dr. We'll substitute, we'll see what we'll get. Sigma into 2 pi r drx by so many terms. What are variable here? Both r and x are variable, no? And x is some sort of fixed here. Here, small r is variable. The only thing is what is the smaller is variable. Now I'll take help of the triangle. I think I'll do one thing. Let me give r here like this. No, you have a triangle. Just take help of this triangle. This is theta x. This is r. What is tan theta from the triangle? R by x. So replace in place of everywhere r you replace with a x tan theta. Let's see what all we get it now. So this is the. You can ask questions. Why you didn't assume two elements? See here, I think you must understand like the disk is made up of elemental structures a ring. Due to ring already we know. So don't assume here one upper here one ring, sir. Here one ring. I think should not know. You have to assume a ring. You know we know due to ring. If I integrate the from 0 to capital R, if small r varies from 0 to capital R, or we'll get the field at this particular point P due to the total disk. Oh, some delay is there. Huh? Okay, now we'll get it. So 2 pi, this R is x tan theta. Okay, dr also we have to admit. So dr is equal to secant square theta d theta. So substituting this d is equal to visibility. I think some problem is there, no? Not. Okay, let me try this one. R equal to x tan theta. So this will be x secant square d theta. One more x. Some delay coming. Okay, fine. Let's see if problem comes, then we have to restart. This should be so many parameters are there. You check it. Here one tan theta. 2 pi sigma g. Let me take it outside completely. X cube tan theta secant square theta d theta. Here x cube will come from the bracket outside. So tan square x cube get cancels. 1 plus tan square theta secant square theta and everything. I think if I simplify this, X cube get cancels. Tan theta is there. From here, secant square theta, secant cube theta, here secant theta will come. So I'll finally I'll end up with only. Is it visible? Huh? What I'm writing, I think for me not visible.
Send is visible.
Visible. Huh? Software. This will do one thing. Okay, let me try to finish off this part. We'll see that one. Huh? Any? Okay, fine. This simplification sine theta d theta. What to do after this? So let me integrate this. Let me integrate this part. D is equal to. So the integration of this is equal to 2 pi sigma integral of this will be minus cos theta. Now what is the limit? The limits are, okay, let me go for the limit here now. So this is equal to, from the diagram, look at what is cos theta, x by, I think it all started from here, no? So what is cos theta? R square plus x square. So that value of cos theta I'll substitute here. So what should the limit? Limit will be 0 to r. Okay, this will substitute all the things. So E is equal to 2 pi put x equal to, put small r equal to 0, will end up this plus 1. So then everything will be 2 pi sigma g 1 minus this is the answer. What? No, there's no problem with the zoom here. The driver, the writing pad is a problem. Huh? It is some maybe God corrupted driver. So there's an answer here. I'll just show it. I think we can't. There's a due to disk is what we got this much here. Now what? So this assumption is very very important. Okay, agree this one. Okay, now put R equal to infinity. We'll see one very important thing is what we are going to get it. Put R equal to infinity. Let's save this. Put R equal to infinity. R equal to infinity means what? Like, now, what is R equal to infinity? So for first, what is R? R is this one, the radius of this. Put R equal to infinity. So how much you'll get? 2 pi sigma g. 2 pi sigma g, that one. So for R equal to infinity, let me go to the next page. As R tends to infinity, then E will become how much? 2 pi. Anything added to infinity will be infinity, root of infinity will be infinity, 1 by infinity will be 0. So final our answer will be 2 pi sigma g. What is sigma? Sigma we defined it as like sigma is m by pi r square. So then what is our final answer? 2 g m by r square. Okay, check it now. Now what do you mean by r infinity? Just this last one will wind up. I think it's troubling a lot, unable to write it, scribble anything properly. Anybody, what you interpret that one? Finally, we brought R infinity. What do you mean by R infinity? Better to remember this formula only. I'm just wrote some in terms of mass if they give that one. So what is R infinity means? It's like an infinite large sheet. So this will become large sheet. Okay, this is a large sheet. So what is the field due to this? Is given by this formula. And what is sigma? Linear mass density. For last sheet, we don't define mass. So therefore, I do prefer this one. And how the field will be? Field will be directed towards left here. So I can just show only the cross-sectional view. The cross-sectional view will be, so the field will be directed in this direction. And it will be uniform. This is sigma. What is this? What are these? These are lines of force, or better say the field will be uniform. It's telling because we don't get any x here, no, there's no x term here. So what is the field? The field will be uniform. And what is this particular thing? You have to call this as a large sheet. This is called like a last sheet here. So like this is what we should find out. So these are things like, see, we have just brought it what for a disk, the disk for ring, from the ring what meant the disk, from the disk what meant I ended up with the last sheet here. I think I'll, why to waste time. 1 hour I'll continue in the evening. I'll inform the timings. Most probably